Okay, I decided to make this video for you guys just to clarify a few things. I'm going to go over the last pre-lab just so you guys can see how I do it, and then maybe you'll learn a thing or two. So first of all, I'm just going to draw out the problem more or less. So we have this cannon that is shooting a projectile, and it has some initial velocity, v naught, and here's the table where it's sitting, and we have where it lands over here, let's say, okay? So to label everything, we have our v naught, we have our angle here, which is theta, and then we have our difference, we have our delta x here, or delta x, so our range, okay? And this is the same thing as, let me get rid of these suggestions. Okay, this is the same thing as our x final. Oops, let me erase that, sorry. Okay. What color was I using? Purple? Okay. This is the same thing as our x final minus our x initial. That's what this delta x is, okay? And then we have the same thing here somewhere. You know, you have this delta y, which is the same thing as our y final minus y initial, okay? So that's what the change in anything is. Change in speed, change in time, change in position, it's all the same thing. So when you're doing your reading, some of you didn't, which is clear, you have this right triangle where the projectile is being launched in this direction, so you have this vector v naught, and so then you have your angle theta, and so from trigonometry, your y and your x, okay, so your sine, just break this up really quick, your sine of theta is equal y, so opposite over hypotenuse, right? So it equals y over v naught, okay? And then your cosine of theta is x over v naught. And so if you're solving for x, or so solving for y equals v naught sine of theta, and so your x equals v naught cosine of theta. And so it's your full v naught, it's the magnitude of this guy, right? It's not v naught x, v naught y, because this is v naught x, and this is v naught y, right? Because it's just it's your x component of velocity and your y component of velocity, if that makes sense. It's not your y distance, it's not this, okay? It's different. So let me change colors and then clarify one more thing. This delta y, your y, you know, your y final minus y initial, typically you can have this be a positive number. It's totally fine. You can have it go down, right? You can have 0 be here, and then minus 1, minus 2, minus 3, so on and so forth. Most of the time we do this, where we say wherever it landed, this is at 0. Like it hit the ground. And then, so you started at 4, then you go down to 0. And so 0 minus 4 is negative 4. So you have this negative number. You can make it positive, it doesn't matter. Alright? It just depends on where you make your coordinate system. But just to let you know, most of the time, this coordinate system, you know, this is going to be a negative number. And I'm just setting you up for, because you guys are all taking physics, okay? So it's important that this idea is set in stone. And so G also can be a positive number. I mean, because if you're doing the same thing where you have this negative, where you have going towards the ground being in the positive change in y, I mean, you can do that, you know, where you're going towards the ground and this is increasing your difference of y, right? But it should be decreasing it. Most of the time it is. Most of the time this is a negative number, and so just to not confuse you guys, try to think of it as this. The Earth is 0, space is infinity, right? Or whatever, very big number. And so you go up in value as you climb up this y-axis, and you go down in value as you're going towards the Earth. And so your acceleration then is actually, it's 9.81 in meters per second squared in the j hat or y hat, direction. Except it's not. It's the minus j hat or minus y hat direction. And the minus can actually go up front, and so you just say negative 9.81 meters per second squared. And you just kind of assume it's in the y realm, okay? Alright, so that's it. So then I'll go ahead and go into our, solving it. So when you're solving for your x displacement, so your x final minus x initial, our x initial is going to be 0, so we just have our x final, right? Because we're setting it at 0, so where the ball is going is at 0, right? So your x final is going to be just that. So really quick, let's just go ahead and write our kinematic equation. So our kinematic equation for this, right? So we have 1/2 at squared plus v naught x, right? Because we only care about x right now. So v naught x, right? Plus, excuse me, not v, but x naught. So x naught. So our initial position. So a lot of times you'll see this: a delta x equals 1/2 at squared, and this is a in the x direction, right? Plus v naught x. And so this again, delta x equals x final minus x initial. It's the same thing, okay? So this is something to keep in mind. And so our acceleration in the x direction, as all of you pretty much got correct, that is 0. And then, so we're left with x final equal, because x initial is 0, right? So x final equals v naught x times x, or times t, I'm sorry. Oh my gosh, I'm so sorry. This is a t, not an x. Times t. Jesus, okay, times t, right? Because it's not in terms of x, it's in terms of t in our equation. Okay, so v naught x times t. And what was our v naught x? We wrote it up there, but it is cosine theta times our v naught times t times this t value. So this is our x final. Most of you got this correct. But then when you went to put in your t, it wasn't quite correct. So we got to do this quadratic formula really quick. And that is our, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. But this time we're going to be solving for t. This is not x, right? This is a t. And then we really need to do this with our y coordinate. And so we'll do t equals, so let's write our 1/2 at squared, where a equals g, right? Minus, no, plus v naught y t plus Okay, now this is where it gets a little confusing for a lot of you, and it's okay. It's totally fine. I didn't knock off points, but why initial? This is your initial point. When everything else is zero, right? When time is zero, that means you have your initial value of y, because no time passed, so it's whatever that initial value is. And this is your y. So if you have, we need to move this over to this side to get our delta y, right? Y final minus y initial. You can write it this way or this way. It doesn't matter. But the vast majority of you did not get this part, just setting it up, and that's totally fine, okay? Because to solve the quadratic equation, you're solving for when it is equal to 0. So you have 1/2 a, we'll just make this g right away, g t squared plus v naught y, which was, what was that? V naught sine theta times t minus, okay, this is where this comes in, minus delta y, because we're moving this over, the y and final over to the other side. This makes this whole thing negative, and that equals 0. So, a couple things to remember. If this is a positive value and this is a positive value, then it won't matter, okay? But either they both have to be positive or they both have to be negative. And I would encourage you to just get used to writing both of them as negative, okay? It's going to make your life easier in the long run if you just assume that going up in altitude is going up in y, right? Just think of it that way. Just think of going up as going, you're counting upwards, away from the center of the earth. Okay, so now xt equals negative, this is our b, okay, negative v naught sine theta. Some of you did not get this negative sign on there, correct? Plus or minus the square root of b squared, so v naught sine theta squared, minus 4 times a, so this is 2g times c, which is minus again delta y, okay? So this is multiplying, so it's going to be positive. A lot of you got that correct, but a lot of you put y naught here. This is not correct. This is not y naught. Delta y is not the same thing as y naught, okay? So that is not correct. All over 2a, which is g. Good. Okay, now, so that's plus, right? Yeah. So this, here's where you have to be careful. So this delta y is a negative number. Negative is plus. And then g is a negative number, so you get negative, negative, plus again, but keep it with the minus because g is a minus already, okay? So just keep that in mind. G is a minus 9.8 meters per second squared, okay? All right. And then this is going to be a negative number down here. So this minus has to cancel out with this whole thing up here being minus in order for it to be positive, okay? So keep that in mind. Anyway, so that is the answer for time. I'm not going to go any further. I just wanted to clarify a couple of those points. So just be careful when you're making your so the acceleration in the y direction, just put that into g, okay? That's what is used more often than not. You can say minus g if you're counting as increasing altitude as being a negative number where the Earth is 0 and this is -1, -2, -3, so on and so forth. But so just be careful with that. I hope that cleared things up. If you have any questions, yeah, just let me know.